FastMCP 3 implements a hierarchical visibility control system through provider-level and server-level transforms, enabling fine-grained runtime management of component availability. This mechanism employs tag-based filtering and explicit enable-disable operations to create layered access control, where provider-level settings establish baseline visibility that server-level configurations can selectively override. The upcoming code demonstrates how a local provider instance establishes initial visibility constraints by disabling admin-tagged components, while the server subsequently re-enables specific tools through targeted enable operations. This pattern showcases the transform pipeline, where provider-level disables are applied first, followed by server-level overrides that determine final component exposure to clients. From FastMCP, import FastMCP. From FastMCP server providers, import local provider. #create provider with visibility control. Admin tools equals local provider. At admin tools, tool tags equals admin. Def admin action SDR. Return admin. At admin tools tool. Def regular action SDR. Return regular. #disable at provider level. Admin tools, disable tags equals admin. #server can override if needed. MCP equals FastMCP server. Providers equals admin tools. MCP. Enable names equals admin action. #re-enables despite provider disable. This code demonstrates the two-level visibility control system in FastMCP 3, where providers and servers can independently manage component availability. The local provider instance, admin tools, creates a dedicated component source with its own visibility rules, showing how providers enable modular organization of tools. By tagging admin action with admin, and then calling admin tools, disable tags equals admin, the provider establishes default access control that hides admin functionality. The server-level override capability becomes evident when FastMCP re-enables the disabled tool via MCP enable names admin action. This layered approach allows providers to set baseline visibility while giving servers final authority, which is crucial for scenarios like mounting third-party servers where you need to override upstream restrictions. The pattern enables clean separation of concerns. Providers manage their default component exposure, while servers handle runtime access control based on application context. The design choice to make server transforms run after provider transforms ensures servers maintain ultimate control over their exposed interface. This becomes particularly valuable in multi-tenant or permission-sensitive applications, where the same provider might be mounted in different servers with varying access requirements. The code also highlights how FastMCP's visibility system treats tags as additive filters. A single matching tag is sufficient to trigger disable-enable actions, simplifying group management of related components. Let's break it down. From FastMCP, import FastMCP. Imports the FastMCP class from the FastMCP module, which provides the core server functionality for implementing Model Context Protocol (MCP) services. This import alone doesn't create any server instance or configure any behavior. It simply makes the FastMCP class available for use in the current namespace. From FastMCP server providers, import local provider. Imports the local provider class from the FastMCP server providers module, which is the default provider for components defined directly in the server code. Admin tools equals local provider. Creates a local provider instance and assigns it to the variable admin tools. This provider will serve as a source for tools, resources, and prompts that are defined directly in the code, making them available to clients through the FastMCP server. The local provider is the default provider type used for components registered via decorators like @MCP tool.
@admin tools, tool tags equals admin. Def admin action SDR.
Defines an admin tool function named admin action that returns a string, tagged with admin for grouping and access control. The decorator registers this function as a tool in the server's local provider, making it discoverable and callable via MCP with the default name admin action.
Return admin.
Returns the string literal admin as the output value of the current function or method.
@admin tools tool. Def regular action SDR.
Defines a function named regular action that returns a string, decorated with @admin tools tool to register it as an MCP tool in the server's local provider. The decorator exposes this function as a callable tool via the MCP protocol, using the function name regular action as its identifier unless explicitly overridden.
Return regular.
Returns the string literal regular as the output value of the current function or method.
Admin tools, disable tags equals admin.
Disables all components tagged with admin by marking them as unavailable for client queries and execution. Components with the admin tag will no longer appear in tool listings and cannot be invoked until re-enabled. The operation uses tag-based filtering, where any component having at least one matching disabled tag is affected.
MCP equals FastMCP server. Providers equals admin tools.
Creates a FastMCP server instance named server with a single provider admin tools in its providers list. The string server serves as an identifier label for protocol handshakes, while admin tools becomes the sole component provider that will supply tools, resources, and prompts to clients connecting to this server. The instance is assigned to the variable MCP for later use.
MCP. Enable names equals admin action. Hash re-enables despite provider disable.
Calls the enable method on the MCP object with a names parameter containing the string admin action. This re-enables the component with the key admin action that was previously disabled, making it visible and callable again despite any provider-level disable that might have been applied. The comment indicates this operation overrides provider-level disabling. FastMCP3's hierarchical visibility control system enables fine-grained runtime management through provider-level and server-level transforms. The local provider establishes baseline visibility by disabling admin-tagged components, while the server maintains ultimate control by selectively re-enabling specific tools. This two-tiered approach ensures clean separation of concerns. Providers manage default component exposure, while servers handle runtime access control based on application context. The design choice to run server transforms after provider transforms guarantees that servers can override upstream restrictions, which is crucial for scenarios like mounting third-party servers with varying access requirements. The use of tag-based filtering simplifies group management of related components, where a single matching tag is sufficient to trigger disable or enable actions. This pattern provides a flexible and modular way to manage component availability in multi-tenant or permission-sensitive applications.
The provider buries the tool, but the server digs it up, same name, same key. Yet one says gone, and the other here.